Thank you, Prof. Ben Israel. So we are starting with our agenda, and the first one that I'm going to invite to the stage is Professor Avi Shaked, who is currently a Senior Research Associate at the University of Oxford Department of Computer Science, where he's leading the development of security by design modeling tool for the UK government-sponsored Digital Security by Design program. Dr. Shaked, prior, he held roles in the research associate at Cardiff University and various R&D leadership and positions in the industry. And he will share with you part of his expertise in interest of system thinking, conceptual modeling, engineering, and other things. And he has chosen one of these topics to share with us here this morning. So Avi, we are pleased to have you here. Please, welcome.
Hi, good morning. So I'm Avi Shaked, and I'm happy to be here and share the work that I've been doing with Professor Tom Elam and Professor Nan Messe about vulnerability management in security by design context. So I will start, sorry, I can't see it clearly, so I'll have to look at the screen here. So I'll start with the problem that motivated us for this research, and that's the DSBD value proposition. So DSBD is the Digital Security by Design UK program, and it's trying to address cybersecurity breaches and attacks throughout the industry and throughout different sectors or across different sectors. And it's trying to do that by addressing classes of vulnerabilities called memory safety issues. And specifically by introducing, if you see the small letters here, this is screenshots from their website. You can go into their website. And it's trying to do it by introducing memory protection, compartmentalization, digital security by design technologies, and specifically Cherry and Morello, if you've heard of that, like addressing memory addresses with in an approach that includes capabilities as opposed to pointers. And we had the problem of communicating the real value, except this number, like this is the percentage of vulnerabilities that this technology is trying to solve. But we had a concrete problem of communicating the value of these technologies with different stakeholders and showing that it has potential to actually have a good effect on the resilience and the trustworthiness of systems. And generally, as researchers, what we do is try to refine or drill down into the problem. But in my research, I typically go up. I try to do a system thinking, to adopt a systems thinking approach. So I'm trying to look up at the general problem, which is the vulnerability problem. And you can get a glimpse or some peek at what the vulnerability problem is from this recent report. It's February 2024, recent White House report that says that the fact that mitigating known software vulnerability, it mentions that mitigating known software vulnerabilities is a complex system problem, which the current ecosystem does not sufficiently incentivize. And a proactive approach is needed to eliminate entire classes of vulnerabilities. And in order to reduce memory safety vulnerabilities, creators of software and hardware can secure building blocks of cyberspace. So this is where it meets also our Digital Security by Design program, as I mentioned earlier. We're trying to do hardware-enforced memory safety. So let's understand what is really vulnerability management, or what are the different authorities say about that. So if I look at the UK NCSC, the National Cybersecurity Centre of the UK guidance, which is also fairly recent, it says that an effective vulnerability management processes allows your organization to understand and validate on a regular basis which vulnerabilities are present in your technical estate, where updates are failing, and to actively reduce the impact of both. Okay, so this is one way to address this. And when we try to understand what is vulnerability by design, which meets our project purpose, then we can go into this another recent document by CISA and a whole bunch of other authorities, security authorities. Secure by design, where they introduce the concepts of secure by design and how it should be handled. And they say only by incorporating secure by design practices will we break the vicious cycle of constantly creating and applying fixes. But that is not, and this is like, as I said, a lot of agencies, including the Israeli INCD and UK NCSC, but in the UK NCSC, it's still patching oriented, even though it was published after that, and it has zero guidance regarding actual design, design-specific guidance for vulnerability management. So what does this Secure by Design document say about vulnerability management? It says that some manufacturers have a vulnerability management program that focuses on patching vulnerabilities, which is also what the NCSC addressed. But more mature programs incorporate extensive data-driven analysis of vulnerabilities and their root causes, okay? Taking steps to systematically eliminate entire classes of vulnerabilities. And they offer three principles, which is, the first one is take ownership of customer security outcomes. The second one is embrace radical transparency and accountability. And the third one is build organizational structure and leadership to achieve these goals. And you can see none of these principles are technical, right? They're all organizational or social principles, and they actually live by their words, which is nice, because they have a series of documents called, that I call Eliminating Vulnerabilities, and they show how these principles apply to various classes of vulnerabilities. But they do not go the extra step and offer a more general approach to handling the vulnerabilities, and that is missing also in the state of the art. So how do we systematically address vulnerability management by design? And to be more concrete, for those of you who like things a bit more concrete, say that we have different stakeholders or different disciplines involved in the design, like systems engineering and security engineering, and each one of them have their own knowledge. How do they communicate the aspects of security and bring that into the table and make design-related decisions about the security posture? So that was what we were trying to solve. And we turn to understanding the domain ontology of that. And so for those of you who don't know, like domain ontology are the main concepts and the relations between them that characterize a specific domain. It's a way to untangle or to address complexity. And we look at, I'll just give you another glimpse of how we approach this. This is not comprehensive at all. I can't do something comprehensive in like 15 minutes. But we look at existing knowledge bases such as KPAC, which is used for attack patterns. And you can see the relations between KPAC and other knowledge bases like CVEs, which is concrete vulnerabilities, implementation vulnerabilities, and CWEs, which is vulnerabilities at the mechanism level, or something that MITRE calls weaknesses. And weaknesses are the root causes of vulnerabilities and are also the root causes of attacks. And when we go deeper into CWE, for example, this is one CWE record, weakness record that we're trying to address in our DSPD program, which is the out of bounds right. We can see that there are different hierarchies of vulnerabilities according to the MITRE organization. And it's a child of another higher level weakness, improper restrictions of operations within the bounds of a memory buffer. And it's also the parent of lower level mechanisms, vulnerability mechanisms. And this is the rest of the CWE record, so you can see that it applies to different languages or technologies. It is manifested by different implementation vulnerabilities, which are the CVEs. And you can mitigate those, the mechanism, by considering different mitigations, such as selecting memory-safe language, or doing architectural design, and so forth. If we look at the CVE record, lower level, implementation level vulnerability, that we can try to look for those from the other side, right, from the lower level side, and we can see that this record is also applicable to what is called in in the domain, the CPE, which is the configuration of different products. You can see different configurations of Linux here, of Fedora. And it can be mitigated by controls, for example, here with an update. And it, of course, there is a link to the mechanism that it manifests. And once we understand the ontology of the domain of vulnerability management, we try to use conceptual modeling to organize that. And this is part of what we came up with, okay? And we use that, I will show how we use that later, but you can see the different concepts that we identified, like vulnerability, which can manifest another vulnerability. So this is the class, and different instances of vulnerabilities can manifest other, reflecting the hierarchies of vulnerabilities. It is applicable to component types, and by proxy to the components that has these component types. And it can be mitigated by controls, which is what this rule says. It says that you can mitigate the vulnerability by having a set of controls in the specific context of component types. So we also contextualize the mitigation strategy. And as a concrete example of that, consider a system where we have two components, a Linux instance and an internally developed application instance, and each one of those has a corresponding type. You can see the type being assigned here. We have the CW2024, which is improper restrictions of operations within the bounds of memory buffer. And we have a security control, which is to use memory-safe languages, and a rule that specifies when it is applicable. So using memory-safe languages is relevant to internally developed applications, and it mitigates CW2024. And we developed a prototype, open source software that allows you to reason about systems designs using first-order logic. This is like in first-order logic. And we have a full implementation of that that is available. And you can see the two components here. And you can see that before, there are no assigned controls in the beginning, and the component is vulnerable. And when we assign a control that is relevant, which is according to this rule, is use memory-safe languages, the control is no longer vulnerable, right? So what happens? So we address, by design, the vulnerability in our internally developed application. So this is like a mechanism to define rules for that. Now what happens if we have a new vulnerability disclosure about the Linux system? And that's like something that happens quite frequently. This is one from earlier this year, a real one, right? And it implements, it manifests CWE2024, and this makes the Linux instance vulnerable. So we can solve this by design by introducing more rules, which is a rule here that says you can mitigate the high-level mechanism using capability-based addressing hardware, which is what we developed in our DSPD UK program. And this can be applied in the context of both the internally developed application or the Linux operating system. And you can specify other component types that are affected, because once you have the hardware, you don't need to worry about some specific software components. And when we do that, and we integrate the control into the Linux instance, you can see it's no longer vulnerable. Okay. So this is how we solve this by design in a scalable way. And back to the principles that I showed you by CISA, we understand that design is a socio-technical system. So if we take this meta model and we can use that to define how our organization works with respect to... Yeah, yeah, of course. We can use that, those definitions, sorry, I don't really like speaking to microphones. So we can use this domain understanding. It's fine, I'm close to finishing. So we can use this understanding of the domain and the conceptual model to organize our methods. So for example, we identify information exchange interface in the form of component types and controls, which can be the main communication mechanism between different disciplines. And I can elaborate on that for anyone who is interested to hear how we do that. So in summary, I showed you an ontology-driven methodology for vulnerability management. There's an automated reasoning mechanism with full implementation that's available here. We were able to identify information exchange interface to address the socio-technical challenges associated with vulnerability management. And this makes vulnerability management systematic, scalable, and rigorous. So feel free to approach me with any feedback. Thank you for listening.